Hello and welcome to AP Precal. Today we are going to study functions and graphs. So let's start. So our first learning objective is to describe how the input and output values of a functions vary together by comparing function values. First of all, let's see what a function is. A function is a mathematical relation that maps a set of input values to a set of output values such that each input is mapped to exactly one output value. So this is very important because if we have a single input value mapped to multiple output values, then by definition it is not a function, it is just a mapping. The set of input values is called the domain of the function, while the set of output values is called the range of the function. We'll see this with the help of an example. So similarly, the variable representing input values is called the independent variable, while the variable representing the output values is called the dependent variable. So now let's see these terms with the help of the upcoming example. So for example, we have the function which is equals to 2x plus 3. So in this case, all the set of all the inputs, which is the set of all the real numbers, is the domain of the function. Similarly, we see that the output of the function would be 2 times real number plus 3, which will always be another real number. So we can say the range of the function is the set of all real numbers as well. So similarly, if we see for the independent variable, so the variable representing the input values, which is x in our case, is the independent variable, while the variable which represents the output values, which is f of x, or we may call it as y, so this is the dependent variable. So the input and the output values of a function vary in tandem according to the function rule, which can be expressed graphically, numerically, analytically, or verbally. For example, the function x square, so it increases as the input value increase, right? So the increase in input value will result in the increase in the output value. So in this case, the both the input and the output values of the function, they change uh, in respect to with each other. So the increase will lead to increase, a decrease will lead to decrease. So now let's define the definition of the increasing functions. A function is increasing over an interval if, as the input values increase, the output values also increase. Mathematically, if a is less than b, then f of a is less than f of b. So for example, if I have a function which looks like this, so we know that from the interval till this red point, for each a less than b, so for example we have a over here and b over here, so for each a less than b, f of a is obviously less than f of b, right? But now if we move beyond the red line, we can say, we can see that here for the green line, if I have a point c over here and d over here, so c is obviously less than d, but f of c is greater than f of d, right? So now we know that this function is not an increasing function over the entire interval. It is only an increasing function from a to b. Now moving towards the decreasing function is very similar, just with the difference that if the function is decreasing, then the output values will also decrease. So for example, if a is less than b, then f of a would be greater than f of b. So it is a reverse relationship with each other. So the decreasing function, they often look like this, right? So you can see that a, and if we label like b, a and b over here, similar, like obviously a is less than b, but the f of a is greater than f of b, right? So for example, minus 3x plus 2 is a decreasing function. Now moving towards forward, we need to understand how the quantities vary with respect to each other in contextual scenario. So if we have a graph of a function which displays a set of input and output pairs and show how the value of the functions inputs and outputs changes. So for example, if we take f of x equals x squared, so now we have the multiple sets. For example, if I write down x and y over here, so I know for x equals 1, y equals 1, which is 1 square. For x equals 2, y is 2 square, which is 4. So once we have these pairs of sets, then we can draw a graph out of these pairs. So for example, here is my 1 comma 1 pair, and at this point maybe I have 2 comma 4 and so on. So similarly, we can form a verbal description of two quantities. For example, if we have a speed versus time graph, so we can verbally say that whether the car speed is increasing or decreasing based on the graph. Now moving forward, we need to know the difference between concave up and concave down function. So suppose a function like this. If we draw a straight line, a straight tangent line like this, we can see that the whole function lies above this line. But if we have a function like this, and now we draw a tangent line at the midpoint, we can see that the whole function lies below this line, right? So we label these two different type of functions as concave up. So this one is, I would label as concave up because it mostly lies above the line, right? And similarly for the second function, I will label it as concave down. So what's the difference between these two intervals? So if we just focus at the rate of change, so for the concave up function, the function is, obviously increasing, but as you can see, uh, the rate of change between this blue interval and the rate of change at this brown interval, so they are different, right? For example, in the blue case, the function only increased by this small arrow, but for the brown case, the function increased by a lot more. So which means that the rate of change is increasing in the case of concave up functions. But as we move to concave down functions, we can see by similar reasoning that the rate of change is decreasing, right? So for example, the function minus x squared would be a concave down function. Now what is the zeros of the function? So a graph of the function intersects the x-axis when the output value is 0. For example, f of a equals to 0. Now this a, the value of x, which made the function equals to 0, that is what we call the zeros of the function. So for example, for the function x squared minus 4, we know that if we substitute x equals to 2, we will get 2 squared minus 4, which is equal to 0, right? Hence we know that 2 is a 0 of this function f of x. Similarly, negative 2 is also a 0 of this function, as you can see over here. So that's all for today's class. Wishing you a good luck for your exams. Bye bye.